All right, and we're back. It is COMP123, and it's summer 2016. It's programming 2. We're talking about C# and inheritance this week, on week 4, part 3 of our broadcast. Last time we got together, we really had this structure up here. I'm going to bring it up so you guys can see it again. We had a bunch of classes and objects here that we made, right? In our person class, right? We have our person class. This is what we're using as now the base class to construct other classes, right? Notice, by the way, I didn't put any inheritance on your quiz because you need more time with it. You need to absorb it more. Inheritance is a bit more of an abstract concept. So is polymorphism. And before we get into that, I want you to really absorb this stuff. Okay, so we use with our person class. We also have a student class we made where I confused the crap out of all of you with stuff. By the way, I've updated it, so I want to show you something down here. You know, we're going to do it today. And I also have a teacher class. The teacher class is another an extension. It extends. We're going to say, we can say that any subclass extends the parent class or the superclass. Okay. So you can see that the teacher class and the student class, they're different, right? But they're related in that there is a relationship with a person. They're both people in our language, right? There isn't a people class, right? But they are both persons, right? That's what they are. Okay. So when we create a subclass, it's like we take all of the instance variables and members of the base class blueprint and we add to it. It's almost like we scaffold up. Like example would be if I was building a house. I got to go back to this again, this example, right? If I build a house and if I build a foundation, and if I say all houses have foundations, that's true, right? Pretty much. Unless it's a stilt house or something. I don't know, some weird kind of house, right? But let's suppose that most houses that are on the ground, they have foundations of some sort, right? So therefore, they inherit the foundation. If I make a foundation, I build the house on the foundation, right? All right, how about this? All houses, I can say this, the set of all houses include 4 walls, right? I think that's pretty safe to say. At least there's 4 walls, at least, that kind of, you know, compose the house. At least 4 walls, let's say, right? So that we have, and there's different shapes to houses, right? Some houses have more than 4 walls, but I'm saying at least 4, right? We can say that too. But it's difficult for us to say that we inherit 4 walls for every house. That's not exactly true. If I say a room has a foundation, it's true. A room has a foundation. This statement is true. Here's another statement that's true. A room, most rooms have 4 walls. Again, is it always 4 walls? Sometimes not. Sometimes there's a big window on one side of the room, right? So we have to be very careful when we say inheritance and we kind of try and relate things to the real world. We have to look at it in terms of business rules. So don't think about the things in terms of I have a house and it has a foundation and so on. It's almost like this. I make a blueprint for a house and now I'm going to extend that blueprint and I'm going to add an add-on. I want to add a module or a feature that blueprint didn't have in my original house. So here's my original house. Maybe it has only 4 walls, right? But my new house, this new one I'm building, based off or extending the new one, I'm creating an extension for the house, right? The extension is going to add on more property to the house, more square footage, if you will. So the shape of my house, this is why we're getting a little bit abstract. The shape of my house will change. It's not going to be just 4 walls anymore. It's also going to have maybe some kind of a bigger kitchen or some kind of additional features that the old house didn't have, right? In that way, when we think about it, a person is a smaller class. It's smaller than a teacher or a student. A student is actually bigger in terms of how the shape of the object compared to a person. Yes. I'm using the person class as if the person class is almost like it's inside the student class. I want you to think of it that way, right? It's almost like we have persons inside all of us, right? Where there's the generic person, and it's kind of hard to visualize this. In real life, if I was going to really do a person class, It would not be a concrete class that I could instantiate. I would never instantiate a person class, because contextually in business rules, I want you to think about this, a person class has no meaning, just like animal. And I want to do another example about this today, a whole new example, because I think I need to do more of these things so you guys can understand object-oriented programming even more, because it'll confuse everybody as we move forward and do some other stuff. Let's focus on what we did last week, though, or last day. So last day I did something called, I had created a list, right? And I created actually another class called course, right? So here's my course. And course has two instance variables and two properties associated with them, right? Course code and course description, right? Those are the two properties, and they're both read-write. I can do both reading and writing to the contents of our instance variables, our private instance variables up here. Okay, so that's all they have. So it's a small little class, and it only has one constructor. The constructor, right? It takes both variables. So both instance, it takes both kind of parameters, and then what it does is it initializes both public properties, right, to store the data in the instance variables. That's what I'm just using the language so you understand. I'm not trying to confuse you here, because when we talk instance variables or fields, class members, whatever you want to call them, a lot of times they're all related. You can hear different things depending on which language we're talking about, right? So this is the only constructor that I've built for the course class, right? And the course class is a standalone class. It's not related to any other class, except for maybe the object class, which is the superclass of all classes, right? So a course is actually a concrete class. It's a course. It makes sense, and it has contextual meaning. However, we need to define what course is containing. A course can have different properties, the name and the description. Okay, good. So I want to create inside my other class, I'm creating an object of the course class, right? But I'm doing it inside of a list. It's almost like I'm creating an array. And what I've done here, if I go back to the top of this person class, sorry, not the person class, I want to look at the student. Here's the student class. The student class has two instance variables. It has the private string variable called student ID. That's unique. That's why it's bigger. I keep saying this again. I want you to hear this. It's bigger, larger than the person class. The student class cannot fit in back into the person class. It's bigger. It has more stuff to it, right? The original parent class is smaller, right? Whenever I extend my original class, obviously I'm adding to it. I'm not removing things from it. And in fact, I cannot remove things from the original class. I can do two things. I can add to it, or I can override what I had from my original class if I set it up so it can be overridden. Right now, my classes are not set up to override anything, right? Okay, so that's how it's bigger, just from the student ID. Second thing that makes it bigger is this new list that I've created. And again, it's a new structure for some of you. Some of you may have not seen this list, what a list is. We'll talk about that a little bit today as well. We'll make an example of a list outside of this class. But really what I'm doing is I'm saying a list is a generic. It's saying, hey, I want to make something that instead of an array that has an order, 0, 1, 2, 3, with different elements, a list is almost like an empty container. I want you to think of it like that, right? I got a list. It's an empty container. And I can have, it's a collection of related parts, if you will, components. A list is a collection of related components, right? And I got to tell the list what the related component data type is, right? So my related component data type is the course. Because I can use classes not just to instantiate just objects, but I can use them as if I'm using them as if they're variables. They're data types, I mean, right? So in this case, I'm using the class as a data type. The data type is course, not string or integer. It's course. So I'm saying let's compose a list, a container, with like components, like I said, of type courses, right? That's what I have. So I have a bunch of course components floating around in this container. And when I say floating around, components don't have an order. If I load them into the, if I spill them into the list container, they exist inside the list container, right? lists have different properties, and lists not only are containers, but they also have their own methods, like classes actually, because they are complex data types. All right, we're composing a complex data type, and we can do that with the list generic. We'll talk about that later. So what I've done here, and if you look at the syntax, is say this: hey, whenever I see the new keyword, if I see the new keyword, I'm composing or instantiating a new object, which means that the list class is a class. It's a list class. But what I'm doing here when I use these angle brackets is I'm specifying what type of list class I'm creating. I'm instantiating a list of type course. And I'm making the variable, the identifier that's associated with this list, as courses, right? So courses is the way we refer to the container that is a list of courses. And that means when I use the new keyword, I'm saying, hey, let's create a new container with a list of courses. However, there's no courses currently listed when I do this line. On line 21, I don't have any courses. It's just a container that can hold courses. Think about almost like a container of containers. That's what I'm really creating, right? And my containers have the same shape as a course. So if I tried to load something else in there, a house, a car, or something else, it won't fit. It's almost like a square peg going into a round hole. It's not going to fit. The shape that the list that I'm creating, courses, is waiting for or listening for is a course shape. No other shape will fit in there. I can't put a string in there. I can't put an integer in there. I can only fit in a course into that list. Okay, yes? Yes, because the course is, no, course is a container. If I create a new course, right, it's my own object, and the object is a container that contains its own properties and methods, right? Now remember that course only has two properties, name and description, and the only method it really has is the constructor method, right? So far I haven't added a course in here, right? All I've done is said, hey, let's create a container to hold courses. That's what I'm doing. Okay, so that's what I'm doing here. And so in this way, I'm using something called a method or a technique called class composition, right? And the reason why it's good is because I can create all kinds of singleton classes all over the place that have nothing to do with each other, and then I can build up a really powerful class by adding these methods or these specialized objects inside my class. So when I extend my person class, not only am I'm really extending it. I'm making it so it's really specialized, right? So I want to tell you this: my person class is way smaller than my student class at this point, right? And my student class is still larger in many ways and different, also different because it also has other things that the teacher class doesn't have, right? So teacher and student, there's little relation. The only thing they know is that they come from the same parent class, person. But when it comes to how large they are and the shape of each class, I want you to think about this abstract idea of the class shape, right? And I know it's hard because we're beginners, right, in the room. So we're all kind of learning the language that we're talking about. And language is really important here because as developers, all right, when you be in your coders, whatever, we all need to share the same language, okay? Here's an example of something that's a little more abstract. And I know I'm talking abstract stuff for a second, but please bear with me. I'm trying to explain it so we understand each other. Because sometimes when a professor talks with a student, in my mind, it's clear because I've been doing it for many years. But for you, it's like, what is he talking about, right? Here's an example of real language I want you to think about, right? When I look at a person, right, and this is just me, I analyze them right away, right? A real person in real life. I don't look at necessarily if they're male or female, but I start analyzing them, especially when I start talking to them. The first thing I can figure out when I speak to them is, are they an introvert or an extrovert? By the way, introvert and extrovert are just labels that I'm associating with the person, right? I'm trying to figure out who this person is in front of me. It happens automatically. I'm not really thinking about it too much. But I can kind of figure out if they're someone who likes to be with other people or likes to spend time alone. You can kind of figure it out when you look at a person for the first time. The way they respond, how they speak to you, are they shy, are they outgoing, are they talky, are they quiet? Usually if they're more chatty, they're more of an extrovert. If they're, they don't like talking to you, they're more of an introvert. These labels, extroverts and introverts, right, are just labels that we have. It's language that we understand, and we start, kind of categorizing. I look at a chair, I know it's a chair because it's a label that I've been taught as a child, right? I look at the sun, I know it's the sun, it's in the sky because it's language, and I know that I can relate the label that tells me that ball of fire, in the middle of our solar system, right? It means it's going to, give me heat. It's going to be a bright day. If I see the sun, it's probably a good day, right? Those things, and I can associate the word sun with it. So I want you guys to start associating the word constructor with what it really means. It's almost like a method, a specialized method. If I say constructor, I want you to think about it right away and say, okay, I know what he means. It's not just a method, it's a special method, right? When I talk class, I'm talking about, this is a blueprint or a template. When I speak about extending the class through inheritance, I'm talking about making the class bigger, all right? My class is always going to be bigger when I extend it or inherit, right? So the more times I inherit, if I have in the hierarchy, if I start off with a person class, and then I have another object underneath it, another class underneath it, like example, the student class. And then I go to the next level. Underneath the student class, I inherit from the student class, right? And I make an international student. Guess what? The international student is going to be bigger than the student, which is bigger than the person, which is bigger than the original object superclass. Always going to go down there, almost like in a pyramid shape. So I want you to always think of that, right? And therefore, I can never take my original my student and fit him into the person anymore. He's too big. He's outgrown the person. He's extended the person. It's too big, all right? However, I can test to see if he's a person because he still has that relationship. I can say, well, all students are part of the person class. That's true. That's a true statement. So I can test for that. And that's really powerful too. An example of that is this: if I have two classes and I'm making a video game, okay? I'm trying to give some other ways to relate to this thing. My two classes are hero and enemy, okay? But they both come from the game object class. Can I say that they're both game objects? Absolutely, that's a true statement, okay? And if I have the enemy class and I extend it, so now there's two types of enemies. I have an enemy that can fly and an enemy that can swim. If I test to see only enemies can hurt the hero, whether they're flying or swimming, it doesn't matter, they're still an enemy. I can test to see what type it is, if it is a enemy, if it is a game object. Those are things I can test for, and those are ways we can use things in programming. Yes.
Why best practices when you're creating lists?
Yeah.
To have another class put the data coming from another class where it's like courses instead of.
Oh, like, are you talking about this?
Yeah.
Where I use a property. Here's what I've done for this property. I've created a property, a public property for the list, but guess what? It's a read-only property. Hold on, Tom, you said that read-only properties can't write. I'm not writing because a list is a complex data type. A list is a reference type, not a value type. And this is why I brought this little picture up here. Let's show you the picture, all right? So here's the little picture I got from one of my colleagues. I can't make this a little bigger, I'm sorry. This is kind of neat, right? But if you see that, here's the reference type and here's a value type. When we pass by a reference, so let's say I pass a cup to the fill cup function or method, right? Notice when I pass a cup that's passing by reference, I use the ref keyword. When I fill the cup that I'm passed, the original cup gets filled, right? When I pass it by value, right, I make a copy of it, right? And now when I fill this cup with the fill cup method, it doesn't fill the original cup because this is a new cup. Passing by value creates a clone of the original cup, right? That's what it does. And it's a separate cup altogether than this one. Where this one is a representation. See how it's a little funny little dots around it? This is just a representation or a pointer. It points to this cup. So I'm not really making a clone at all, right? What I'm doing is and see how there's a difference this is why this little animation is neat, right? This one, it's almost like a shadow or a ghost of this one, right? Whereas this one is actually a new one, right? So this is the same thing that we're doing here. When it comes to, and this is why I want to talk about these concepts, because if you don't nail these concepts in your head, guys and girls, when we do other more advanced stuff, you're like, well, I don't know what he's talking about. How does this work? You know, this is stuff that we have to understand in our heads first. You're going to get this from other courses as well, but I want you to nail it down here because it's important, right? All right, so going back to this then, going back to what we said, I can do a list. I can return a list, right? I can do that. And what I'm doing is I'm returning a reference to the original, which is up here. That's all I'm doing. So here's my original course. So when I return a reference, because I'm not returning a value, I'm not passing a value like we do with other data types, right? I'm passing a reference. That means I have access to the original. If I have access to the original, I can do all the methods and everything else that I can access to the original. So in fact, I do not ever need more than a getter for any kind of public property that I use to associate with a list. Okay. In fact, if anything, it's like I'm exposing the list itself. Okay. So when I make this private and this public, the only advantage to this is that I can do other things in here, right? At the same time that I'm passing a reference, I can do something else. Whereas when I just pass the list itself, I can't do anything else, right? I can only do operations on the list. You'll see what I'm talking about. Example would be a scoreboard. Okay. In a scoreboard example, I'm playing a game, and I have a scoreboard with a label, and I want to update that label with the new score. So let's say we're playing a game, and the player scores, right? So what I do is I use the get accessor method, right, to get the value of the original score, right? And then I say, okay, take that original score, add whatever points I got to it. Let's say 100 points for killing an enemy, right? Okay, I got that new value. Now I'm going to set it back to the original. When I use the setter, I don't just set it. I just don't store it. I can also display it on the scoreboard, because I have room in the setter. Any kind of setter, I have room to do other things other than just set it. It's a method. I can do other statements in there. And that's why we use setter. We also use setters and getters for validation, to make sure before it gets added in that the value is correct. I don't want to set up my program to crash, right? Example: if I'm listening for an integer, but the user enters a character or some kind of other string, right? I can check for it inside my setter to say, is this a string? Or is this an integer? If it's not an integer, then send a message back. Do not set this. Like I could do something like this. I could say, if here's something I can do in my setter, and check this out. This is actual valid stuff that I can do, and make it a little bigger so you can see it. So let's say, for example, in my student ID has to be a string, right? But what if it's not? What if my student ID was supposed to be actually an integer for some reason? I could do something like this. If value, I can test for value. If my value is is not equal to something. Let's say my value is not equal to, I don't know, 0, then I can put this inside of an if statement. I'll never be equal to 0 because my value will always be a string, and that's why it's giving me this error, right? But I can also test it. I say, well, if my value is not equal to end, if I can test for a string, then you know what? Put in something. But if my value for the student ID is equal to end, then don't assign, right? Like for example, if my value is not equal to end, I'm making this up by the way, and this is not a great example, then do this, right? Otherwise, else, I can do a whole loop of stuff, right? I can do a for loop in here. I can do all kinds of stuff. It's a method, guys and girls, right? I don't have to stop myself at just doing an assignment statement, right, with my value. I can do other things, and that's why it gives us value. I'm not going to do much more in here because I don't want to confuse you more, but you can use accessor methods. I want you just to be able to understand that I can do that, so that way, that's the reason, the advantage of using these things. The disadvantage is sometimes when you see a property, you're like, well, why do we use a property here? Why don't we just expose the private instance variable already? It just makes it easier. And in some languages, you know what? Like for some examples online, you might see it that way. Doesn't mean it's right. The right way, the best practice is we want to follow something called information hiding or encapsulation. Those two things, information hiding and encapsulation, are synonymous. They mean the same things. All right. We want to encapsulate. Actually, encapsulation is a specialized form of information hiding. But what we want to really do is say that we want to hide the way our functions and methods work inside of our classes. Our classes are a black box to the user. All right. All we want to do is expose the methods, and anything we want to expose is is what we choose to expose, not, it's not a random choice. It's not something that just happens by chance. It happens because we choose to expose those things. Now we have control. If we just expose everything, then there's no control, right? Okay, enough about theory. I want to talk about it a little bit with you because I still think people haven't quite latched onto this whole thing. All right, so we did this list of course thing, and then if you notice, going back to the program, if in my driver class, what I'm actually doing is I'm setting the courses, and I've set 2 courses up for you. Here's my 2 courses. I've set COMP123, and I made this while you guys were away. I've updated my GitHub to respect this. So what I'm using is I'm using the add method of the courses list. That's what this is, right? I'm at the add method of the courses list. So remember, courses is actually an object, right? That belongs to the student class right now, or the student object. So there's an object that belongs to the student object. And I'm using something called method chaining, right? If I see dot, and I can keep doing the dots, right? I can keep adding on because I can keep chaining methods and classes one after the other, right? So here's courses add. I'm adding something. And now here's something neat that we haven't seen before. This thing, instead of creating a new course name, like I could have done something like this. I could have said, course, right? And I'll say something like this. I could have done this, okay? So I just want you to follow me for a second. This is my thinking. I could have done course COMP123, right, is equal to, it's my course, a new course. So I have to establish a new course, just like an object. And I want to pass in there the same stuff that we have in here. So I take this stuff right here. I could have done this way, okay? I want you to see this. See me when I talked about this kind of stuff so you understand. I could have done this, okay? And I could have done course, COMP125, just making these variables up so they look the same, not that they're anything special. They're equal to this. I could have done this, right? So let me just kind of take this and copy it and put it in here and paste it. Okay, so I could have done this. And instead of me doing this that I've done when I add a course, I could have just added a variable like this. I could have done something like COMP123, because that is a course. That has an is-a relationship. And this add is listening for a course. That's what it's listening for. So I can pass a course into it because that's what the courses list is listening for. It's waiting for the shape of a course to be put into the container, right? Same thing with here. I could have done this over here too. I could have said something like COMP125, right? And push that in there as well, right? Here's what I can't do. I can't assign an integer or a string because courses they're listening for course type, right? These are course types. COMP123 and COMP125 are both course types, and if you hover over them, you can see that they say that course. They're of type course. They're not of type string. They're not of type integer. They're of type course. These are the new data type we've defined by creating our class. I know I'm repeating myself over and over again, but it's really super important for you to hear me. Because if you get this, right, then you'll get class composition. Okay, but why, if I do this, why would I do this? Because this has I'm never going to reuse COMP123 and COMP125, chances are, right? So therefore, I can create something called an anonymous object. So this is a named object, going back to what we talked about in JavaScript. This is a named object, an object that I've assigned an identifier, right? This is an object here, this part. If I just did this, this is an object that I can create with nothing, right? That is an anonymous object. There's no identifier attached to it at all. And those are options that I have. So what I can actually do is what I did before, which is instead of creating an object first with an identifier attached to it, so some kind of name, friendly name for the object, I don't need it. I can use an anonymous object, right? Why is this really cool? Because in a for loop, right, I don't have to declare an object with a name. I can just use new course. And then whatever that new course is going to be called, it's going to get an anonymous, can create an anonymous object, and then I'm going to pass that anonymous object into the list. Okay. So let me just show you what I'm talking about here, right? So again, going back to what I had before, I'm just going to undo. I had this, right? It's the same thing as what I just did with declaring an identifier, right? But this is this is an anonymous object that I'm passing in to anonymous course object. Here's another anonymous course object. So these anonymous course objects are still being passed into the container that is the courses list, right? And that courses list belongs to my student, right? So now if I was to test this out, I've made a new little method for you guys to take a look at. If you guys look at my GitHub, you see the method, or you can look up here. If I go to my student, I have a new method called show. Here's my show course. So here's my studies. And down here, I have a new method called show courses. Now this method, show courses, that I made, right, I'm using something called a for each loop. You guys have seen for each loops before, yeah? So what a for each loop says is this. I'm going to declare a course variable of type course that's going to store the information about each course object that exists in the list, right? And then what it's going to do is going to go through the list, check each of the objects in the courses list. And by the way, I've used the direct way of accessing the courses list. I could have also used the getter, right? So I could have said this courses with capital C, same thing, right? And then what I'm doing is I'm going to take my console write, and I'm going to write the course code out and the course description for each course that I have in my course list. That's what I'm doing. So I'm actually just iterating through each of the entire container of courses, and I'm looking at each course that I've added into the container dynamically, right? And I'm counting. And let's see what this produces for us. So I'm going to save all, and then I'm going to do a Control F5, right? So we can see run without debugging, and this is what I get. Tommy says hello, because Tommy's a student. Tommy studies, right? Course list. Here's his course list, right? And this is Tommy's course list, right? I've got COMP123, Programming 2, and then COMP125, Client-Side Web Development, right? Those two courses, the reason why I have them coming up, right? This is coming up because of that new method I made called show courses, right? But there isn't, I don't have 2 lines in here. I only have 1 line, but it's going to iterate. It's going to continue to print out these lines over and over again because it's inside this loop. And notice I've added these 2 courses in there. If I had another one, let's add one more, right? So I'll say Tommy.courses.add, right? I'm using the add method. I'm going to add a new anonymous course, right? And inside my anonymous course, it's going to take 2 variables, right? 2 string literals. 1 is the name of the course, or the ID, the course code. I'm going to call this COMP123, right? And then the name of the friendly description of the course, which would be something like, you know, web game programming, right? Okay, good. And now I'll finish off this statement. So I've added 3 courses now. Now you just saw me. I added it dynamically. Before I had 2 courses coming up, I've added it dynamically to the course list, right? And when I run it now, what you expect is what happens. I have all 3 coming up, right? And this is a dynamic list of courses. This list of courses do not have indices. I don't go here and go course 0, course 1, course 2. I didn't do that. Courses 0. I could though. I could, if I wanted to. Can I treat a list as an array? Let's see, right? Because it's important to understand the differences between a list and an array, right? So could I do something like this? Could I say Tommy.courses0? Console log that. You know, let's say console write line. So if I do console write line, could I do something like Tommy.courses, and then can I put a 0 in there like that? Like how we treat a list like an array. And what would that be anyway? What do you think that would be? Yeah. And I'll show you why. Because if I save it and run it, I just want you to understand what's happening here, right? And by the way, I would never do this with a list because a list can have thousands of members in there, right? So let me just do this for a second. So Control F5, right? It prints it out. But take a look also what it does, right? So here's what it does. COMP123, you know, summer 2016, lesson 4 course. How come? I went to 0 and it doesn't give me the details of what this is, right? How do I get a value from 0? It just looks at the course itself. Actually, it's passing back a member of the course class. That's what it does. It doesn't actually pass back any of these list items, right? Notice that? Right? It's not because I can't do it this way. It's because this isn't exactly what you would expect. It says, look what it says, represents a 32-bit signed integer to browse the net framework and what it is. So if I kind of do one of these with the square brackets, right? This script with a square brackets of 0 inside, right? What if I pass in something else, some other reference like 1? What does it give me then? Can I do this? Does it have an index? Can I index a list? I'm asking, you know. And the reason why is because I want you to understand the differences between a list. Can I do anything different? Do you see anything different here? No. How about if I don't even pass the square brackets in, right? I don't do this at all. How about I, you know, do one of these? You know, what happens there if I pass just the course's name without anything? What is that? Would that be any different than what I've already done? Here's what you get. System, collections, generic, list, right? And you get what the generic list type is of COMP123. That's of type courses. That's what it's telling me back. Okay, so it's very weird. The language, you know, along lists this way is weird. What about if I use something else? What if I go courses, and if I open the bracket there, can I do something else like that? Is there some kind of syntax to tell me like courses 0? No. And what else can I do with a list, right? Because we're just doing lists for the first time, and I'm gonna take up lists with you guys again. This is not the last time, all right? So if I go dot, I have all these things in the list class. Oh my gosh, like there's like tons and tons of stuff here. I can go add, I can go add range, I can go any, as parallel. There's a bunch of stuff that I can probably do. Average, binary search. That's interesting. Can I do a binary search of, you know, something like this? Can I search for, you know, one of these courses? And can I search by course code? Is that possible that I can search a list? Yeah, man. It has all kinds. How about clear? What does that do? That clears the list. It cleans it up. There's no more nothing in your items anymore, right? And how about other things too? Can I look for contains? What does contain do? If I look at contains, it says a list. If I use the contains method, it says determines whether an element in the list is in the list T. So I have to look for a specific course item. I can't look for something that's you know, the actual string that's in a course item. I have to search for both a course item that matches both parameters, right? So an example of this would be something like this. If I want to search to see if there's a list that one of these items that exists, I have to pass in. I have to create a new course object with both parameters filled up, right? And then I can compare it to what the list has of inside of it, and I'll get a true or false. So lists are really powerful. You can't do that with arrays. Okay. And then by the way, you can list count. Count is the method that says how many elements do I have in a list. I don't use list length. It's count, right, for lists, right? Let's see what else you can do here. And I'm just going to bring this up so you can see. Lots of stuff. Join, min and max. Here, if I go max, right, it says, hey, when I use max, it says it's an IEnumerable. That's an interface type. And it basically says I can see what the max courses are. And that's kind of a weird thing. I'd have to define that and what that is. And here's one, remove. Remove is one of the most common items in the list too. If I want to add something to the list, like with the add method, I can remove an item with the remove method. So if I drop a course, I can remove it, right? If I add a course, I can just simply use the add method to add it into the list again, right? That's something else that happens. How about reverse? What does that do, right? Reverses the order of the elements in the entire list. Wait a minute. The elements have an order, right? How about other things? Here's select. Select says it's an IEnumerable again. It's a type of operation you can do, and it'll select an object in the list. Okay, if I want to do that. I'll keep going to make sure there's other stuff. Here's one, sort. Right? I want to sort the list. Sorts the elements of the entire list using the default comparer. How does it do it? It depends on what the list items, how the list items are arranged, right? And the list is a type of course. Each course, remember, has two properties, right? A name, a code, and a name, right? These two things. So it's going to sort based on both properties. First the first property, and then the second property, typically, right? And you can also make your own sort method if you want to. All right, this is neat. I like this, right? We talked about lists. Can I make my own list? Can I make my own list, right? It's a built-in method, right? that comes with, you know, with C#, can I create a C# class that extends list? Yes and no. Let's see what I can do here, right? So if I make a new class, let's see if some things that can work and some things cannot, right, for list. Because list is a class. It's an object that I'm making, right? So I'm going to kill these things here for a second. I'm going to go back to the class. So if I want to create a class, let's make a new class to experiment with. We want to do some experiments here, because otherwise, if we don't, then you won't understand exactly what I'm talking about all the time. Let's make a new class. How do I make a new class again? I right-click on my project, and I'm going to go Add. And if you've done this before a couple times, you're going to have class down here. If not, you can go to New Item, and then you pick Class at the top. Let's call this My List. My List, right? And My List is just a generic class right now, but I want to extend the built-in list class. Can I do it? That's the question I'm asking. So let's try this. So we'll say :list, right? And if I go over here, right, then I have an issue. I can't just do it like this, because list doesn't have that as the only constructor. In fact, if I start typing list, you can see the code hinting that I'm going to get. I have list, linked list node, a sorted list, right? There's all kinds of other stuff in here that I can do, right? I definitely don't want to make a linked list, right? But what it's looking for, because it's a generic, right, I need to put in what type of list I'm extending. But I could do it. So let's say, for example, my list, right, is going to extend regular strings or regular integers. So not only is it an integer list, but maybe it has some other properties. And typically, we don't add things to lists, like properties and stuff like this. But let's say I want to make my own for whatever reason. I could say, well, you know what? This list, my list, is an integer type list, right? That's what it is. So it has an is a relationship. This my list is a list. Okay, that's what it is. But in fact, what I want to do is I want to add a method to my list, and my own method. And let's say my list is going to be, I want to make a print method. So I'm going to say something like I normally do: public, right? Oops, public void, print, right? My print method. It's part of my list, right? And what is it going to do? It's going to say, I don't know, something weird and dumb, like I'm printing. I don't know what I'm printing right now, but I'm just printing, right? It's a method. It's a behavior, right? So now, do I have a list? I only have a class. So in order for me to instantiate this object of my list type, let me just go back to program for a second. So here's my driver class, and I have my list class. My list is what the class is called. I want to make a new object of my list, so I have to give it its own name, or I can create a anonymous object of my list. Let's do it right at the bottom down here so we don't miss out, right? So right at the bottom of my driver class, I'm going to create a new variable, and we're going to call it, it's going to be of type my list. So say my list. Notice it turns green. My list, when it turns green in C# like this, it means it's a class, right? So I have my own class, and I'm going to call this in lowercase, my list. Let's say we'll call it my list. This with a lowercase m. Okay, same thing is equal to a new my list. We'll call class my list object. And do I have to pass in the type? You know what? One thing I don't have to do is do the type, because it's defaulted to an integer. Because I've made my list. Here's my list. It's already passed in a default type of int. Right? Now, there's other ways of doing it, so I don't have to do that. But now this is what my list has. My list has all the properties and methods of a regular list: the add method, the remove method, the sort method, all those things we saw, plus my own little method called print. Right? Let's see if it's there. Right? So we're gonna, and so that's what I want you to understand. So my list dot, and you can see that it has add all these different things right in here. Like, for example, I could use the add property to add in an integer item. So integer, I could put in a 1, right? That would work. And I can maybe my list, I can go add another one. I can go, I don't know, 5, because that's an integer. And then I can go my list at the end clear. So I want to clear the list up, so it kills everything that's in the list. I can do that. But I could also do my list dot print, because that's my little function that does everything, right? All it does is print. I'm printing, right? The idea here is going back to inheritance. I can inherit, I can create a subclass of any class that I have access to, whether it's built in C# or whether it's my own custom class. That's what I want you to take away from this little thing. One more thing about lists. Okay, so we got this nice little funky list. What happens if you remove my class? So somehow, we haven't done this yet. I've added a class into in my project. Now what happens somehow if I remove my class? Let's see what happens. So well, how do I do that? Go here, right click, delete. Okay, now I got a problem, right? Because my list doesn't exist anymore, right? So if I was to save everything, notice that I have no object of my list type, so I'm getting an error. Because inside my namespace, which is the name of my project, most likely, I don't have any kind of class of my list, and therefore can't use it. That's what happens if I delete something. I'm just putting it out there. I know you probably can intuit this, but just in case you're like, I don't understand why I can't make my hero into a superhero, and then you're just trying to make a superhero class, and you're trying to inherit from hero. Well, if hero isn't in your project, you can't make it a superhero because you can't inherit from it because it doesn't exist in your namespace, right? So it's the same thing with what we're doing here. We can't make a my list instance variable of a list item that doesn't exist. So this is even, and by the way, look how it doesn't give me errors here because this idea, C# is trying to figure out what I'm trying to do here, right? So it knows it's probably a list, but it doesn't understand. And if I do control dot, it'll give me some options here. It'll say, hey, do you want to generate a class called myList, right, in a new file? Do I want to generate a class myList here in this file? Do I want to generate a nested class, different types of classes? Do I want to generate a new type, right? What am I looking for? What are you trying to do, Tom? Is what is what C# is trying to figure out. Okay. And by the way, FYI, ladies and gentlemen, right? When I do testing, and I do testing, I don't test with existing classes and methods. I create them as I test, right? That's the real way to do it, right? So I'm going to get these curly little, red lines, right, happening. These underneath my stuff, and I'm going to say, okay, cool. So what I'm going to do, I'm going to generate my methods from my test. That's how it should be done, not the other way around that we've been doing. We have a method, and we're pointing a test at it. That's what we're doing, right? The other way, the test-driven development method is we have a test, and it really covers our business rules. These are the things that the test is supposed to do, and we generate our method from the test. That's true test-driven development. We're not there yet, okay? We're not there yet, but that's the real way to do it. All right, so let's kill this, and let's talk about lists a little bit more, right? So let's use a list, a real-life list. I want to make a list of strings, right? And just so you understand lists a little bit, because we have to talk. This is another little object that we're adding in, because lists is a complex type. Because we're talking about classes and objects and inheritance, it's good to understand a complex type. And it's a generic. We call it a generic, and it's also a collection of like objects. That's what a list is: a collection of like objects that we put inside the container, right? We made a custom list, course list. We're going to make a regular list, a string list. All right. So this is how we do it. We would define it like this. So list, right? And we type the type inside there. Notice that when you hover over it, IntelliSense tells us that there's a capital T inside here. See this capital T? Whenever you see this, it means, hey, give me the type that you're looking for. What type of list do you want to make? I want to make a string list. Okay, so let's do string. Put string in there, right? Okay, that's the first thing. So string type list is what I'm making. Cool. Okay, notice the string turns blue, because string is a keyword, right? All right, good. That's the next piece. Now I need to make an identifier for this list. I don't know, like for example, let's say I want to make a list of names, right? So I call the list names. Okay. Now that's the first thing. So it's a list of names. That's the context, but the names are all strings, right? Okay. Now I'm going to say, in order for me to instantiate this list, I can do this, new. I have to use a new keyword because list is a class, and I'm creating a new object from the class. This is just a built-in object, right? Or built-in class. And I'm going to do the same thing. I need to specify both things again. I can't just do list. That's not enough. I have to do list of string. And notice it gives me that as a pop-up, as an IntelliSense. It tells me, hey, if you're putting a list string on this side, you need to put a list string on this side, right? That's the new one you're making. So list of string type. This isn't enough. I can't edit here. I have to use open bracket, close bracket. That's the syntax for making a list. right? So I'm saying make a new list. Just like, imagine if this list with the angle brackets, this string type didn't exist in the line, right? I want you to visualize it, like just like blot it out for a second. If it was if I had a list class and there wasn't this thing, I can make any list I wanted, right? Then all I have to put it on the other side is a opening and closing bracket. I wouldn't need this, but you still need an opening and closing bracket if you have this, because opening and closing bracket means make a new, call the constructor of the list class. That's what I'm doing with the opening and closing brackets. Now this list class doesn't take anything. It's not like I can put something in here. I can't do, you know, hello. I can't do that because there is no constructor like that. If you hover over, it says it's a series of Unicode characters, right? But the reason why I'm giving me an error is because I can't do that. The error is this list doesn't take an argument. Lists don't take arguments like this. They create an empty container that I can add stuff to later. So in order for me to add things into a list or construct a list, the reason why I have to do this is if I want to add a bunch of names, like for example, I want to add Mary, Mark, and Tom again. We've been using these names again. I would do something like this: names dot, and one of the ones we can do it is add. We talked about this already. We can add a name, and then the name is Tom. Right? There's Tom has been added to the list, right? And then I can do the same thing: names dot add Mary. You know, and then let's add some other names. Names dot add, right? Rudvik. Because, you know, I got to add a different kind of name here and there, right? Rudvik's a good name, so it's a sexy name, right? So we got to put it on, right? I'm just saying, these are the kind of things we can do. So depending on how we do stuff, I have got 3 names that I see that I'm adding onto the list. Now, how do I retrieve those names? A for each loop. That's how I do it, right? So I create a for each loop underneath this. And by the way, C# has a really cool, quick way of doing it. If I go for each, and if I go tab, right, tab, it gives me the structure for the for each loop just from the get-go, right? And notice the default structure is this: an item, right, whatever the item is, I used to have to use the in keyword of a collection, right? Well, what's the collection I'm talking about? It's the names collection. So let's put names in there. That's how I build up my iterator. Give me a second while my C# and my Windows goes crazy. Okay, so here's my names. So names is a collection. It's looking for a collection on this side of the in. There's 2 parts of the in, on the left side and the right side. The left side of the in keyword needs an item that you have to define, right? And usually the item is of the type that you're looking for. An example of that is, it's got to be this type, right? String, this is the type, string name, right? In names, right? So name is a string type, right? And in names, each string in names, right? Because remember, these are strings that are inside here. So I'm looking for each name in names, right? For each of these, I want you to console log or console write. Console write. I love these errors. Name. Right. So name, even though I'm not accessing it with a square bracket or whatever. Don't add in there. I'm going for each of the names in the list. I want to output them. And this is a much more efficient way of doing it within a for loop. I can also do the same thing with a while loop. I can while there's no more names, while names is still there, not at the end of the list, I can use it. But this is the most efficient way. So for each name in names, print out the name. Let's see what it does. So I'm going to Control F5.
Would it be safe to use var as well, or no?
We'll talk about var in a second. Where is this identifier expected? Where am I getting this identifier expected here? Oh, that's bad. I forgot to put that in. We'll leave that alone. So yeah, let's try this out. Control F5. All right. So when I do this, you can see that I got the following. Tommy says hello. Here's my list of courses. Blah, blah. Tom says hello. You know, Tom teaches. You know, Tom teaches, and then I go Tom, Mary, and Rudvik. There's my list. Not very descriptive. How can I fix this? How can I make it pretty in the console? Well, I would do that inside my for each loop, right? I would do something like this. You know, if I want to say I want to count how many names are going, right? I can create a variable that's outside of my for each loop, like this. I could say something like, I don't know, int count. right, is equal to 0, I could do something like this. So count is equal to 0. And then what I could say is something like this. Well, each iteration, I want you to increment count. So count, after I'm done printing it out, sorry, right? After I'm done printing it out, I could do something like this, count plus plus, just like I normally do any kind of while loop or whatever. It's separate. It has nothing to do with, the count has nothing to do with the for each. I'm just going to use it as a counter, let's say, right? And I could do something like this. So I could say name, number, and then plus count, right? And then I can build this up here so you can see what I'm talking about. So you can build up, the pluses concatenate, right? I can say name, number, count, right? Space is, space, whatever, right? So I can do that for each of the iterations. And then I probably want to make some separation between what I've been printing up here with what I'm printing down there. So maybe I want to add in some kind of console write line down here. So maybe I'll do one of these, right? Console write line, separate stuff. Maybe I want to add another console write line to make it nice, right? This is the lazy way of doing it. There's way other ways to do it. So let's say, for example, I want to, I don't know, add a bunch of pluses, right, just to separate it out. Who knows? You can make it nice. And then when I'm done printing the list, I'm going to take the same console write line to decorate this. So we don't have any UI, right? So we're just, we're making our own. And then kind of frame what it's going to say. You can totally do this kind of stuff, right? And if I control F5, then you get one of these, right? Name number 0 is Tom. Name number 1 is Mary. Name number 2 is Ludwig. But they're not positions in the list. They're just, they're floating inside the list. Why am I talking about lists? Because we're going to do another example today with lists, right? And we're going to do another example today with class composition, right? So I got to show you this stuff so you see it, and it's recorded so you understand. I'm going to make a new example, and my example after the break, when we come back, right, is going to be around a deck of cards. And I talked to you guys about it, some of you last class. I'm going to create a deck of cards, right? When I create a deck of cards, think about what I'm doing with a deck of cards. Who does not know what a deck of cards is, first of all? Is there anybody who doesn't know? There might be some people. Okay, so a deck of cards is, think about cards with, they have, like playing cards, we play cards. They have, I better show you, right? And again, it's a cultural thing. So some people may not know, and it's totally cool, right? Just like dice, because some people don't know what dice are because they don't have them, right? So if I go cards, a deck of cards, I look what it is. It looks like this. So here's our images for decks of cards, right? They have, a deck is made up of different cards, like they're actual physical cards, like this. And there, you can stack each of the cards, and each card has a value and a suit, a little symbol, right? Listen to what I'm saying. Each card object has a value and a suit. Okay, let's extrapolate this. How many suits could I have? 4 different types, right? I could have hearts, diamonds, clubs, and spades, right? Hearts, diamonds, clubs, and spades. Those are the 4 types. Have you guys done enums before? Have you? Yes or no? Okay, well, okay, we won't do that. I'll confuse you guys then. But let's say if we have these 4 types, this is the only types that you can have. Clubs, diamonds, hearts, and spades, or whatever. These are the four types. If that's true, right, then depending on which type that I'm choosing, clubs, diamonds, whatever, I have a suit and I have a value. So that's my card class right there, right? Okay, now I'm going to have a deck class. This is what I'm going to do after the break. My deck class is a deck of cards. It's a list of cards. That's what it is. So deck is the identifier, the name. Deck is a list of type card, right? Card, I have a bunch of cards. Deck is just the name of a collection of cards of different suits and values. Okay, that's what it is. I want you to play with this. And I'm going to shuffle the deck. I'm going to deal from the deck of cards, right? And I'm going to get a different value every time. How do I load up the deck of cards? How do I do that, right? Because we're utilizing classes and objects here, right? And we're talking about inheritance this week. But I also want you to understand complex objects. Because as we go on, I'm going to give you some other stuff, and you're going to go, I don't get it. I don't know what how do I do the solution, This is how. Let's take a short break. When we get back, we'll do the whole deck of cards, you know, example, right, in our little driver class.